So good morning to everyone that has just joined us, and hello if you are watching the replay of this webinar. Welcome to another one of our online learning webinars, this time all about the advantages and use of electronic leak detection systems. I'm your host, Andy Ferguson, and joining me this morning to take us through the webinar, I'm pleased to welcome Simon Dobson, MD of Buckley's International. We are about to start the main presentation. Now, for those that are just joining us, if you do want to pose a question over the course of the webinar, if I can point you just to the chat facility on the left and the right-hand side. If you're on a desktop, if you're on a mobile device, you just need to pull up and you'll see the comment box in there. At any point over the course of the webinar, feel free just to chuck a question in there. Similar as well, if you disagree or if you just want to comment on anything that we have got. Simon, if I can just get you just to put that screen back, just one back. There we go. Sorry about that, folks. Yes, if as I was saying there, if you do have a question, you just use that chat facility there. Again, if you want to email me your question, you can just at andy@property-care.org. That's andy@property-care.org. That goes for both for the live listeners as well as if you're watching the replay of this. If you are, of course, socially savvy, you can use our social media channels. Just use the native messenger there and send us your question. So, Simon, I can see that we're pretty much on 9 o'clock. Electronic leak detection systems. I suppose I've been fortunate to hear a little about this during the International Structural Waterproofing Conference. But there's a lot of people out there that are maybe kind of questioning, how does this technology actually help building, surveying and construction professionals? What exactly are the advantages of using it? How practical is it to use? And I suppose most importantly, are they any good? Now, Simon, this is our last webinar for 2022. I'm hoping you'll make it one that everyone can remember. So I suppose without further ado, over to yourself, good sir.
Let's hope I make it one that people remember for the right reasons. Good morning. Firstly, to introduce myself, I'm Simon Dobson. I'm a chartered mechanical engineer and I've spent most of my career in the automotive industry, both in product engineering and project program management. Way back in 2007, I was asked to open an engineering centre for a tier one automotive supplier and dragged my family out to India, which was an amazing experience. I'd already worked in the EU and spent some time in the US, but this was really quite different. We came back in 2010. I joined a lithium battery manufacturer with factories in Dundee and Poland, so the travel didn't stop, and I joined Buckley's as MD in 2016. The photo was taken in front of the Motor Guzzi factory in Mandello del Lario, which is on the banks of Lake Como in Italy. The factory was 100 years old last year. They celebrated their centenary. So my wife and I made the pilgrimage in September this year on my 45-year-old motorbike. Buckley's brothers, Derek and John, the Buckley's brothers founded the company back in 26. So we too are very near our centenary. The company was incorporated as Buckley's UVRAL Limited in 1942 and has been in present ownership since then. The UVRAL refers to ultraviolet ray arc lights, which were a major part of our production, initially for photography, more latterly for water purification. We are now the leading UK producer of high voltage leak test and detection equipment, and additionally produce non-destructive test equipment for land and marine corrosion detection and monitoring. We're based down in Folkestone, where we carry out all the design, development and manufacture of our products in-house. Today, we're interested in electronic leak detection as applied to the waterproofing of buildings, both the roofing and the structural elements, such as podium decks and underground spaces. I'm going to outline the key technologies that are used. You can see them here on the slide. And I'll talk briefly about each one of them. And there'll be a couple of very short videos that will show two of the technologies in action. Finally, I'll summarise the strengths and weaknesses of the different approaches. First, though, I'd like to ask Andy to conduct a quick online poll to get an idea of the range of experience in leak detection. So if you could please select from the options, Andy.
Well, folks, here, this is, as Simon just said, I've just kind of chucked the poll out there. This is just to kind of give us a gauge of experience here. There really is 3 options just on there. No experience, have used it in the past, or you are a regular user. And this is just to kind of help Simon just shape the presentation just for all. So if you can, just anyone, just chuck in your answers. I'm just going to leave it for maybe another 5 seconds or so. So just 5, 4, 3, 2, 1, and I'm just going to end the poll there. So just Simon, just for your knowledge, 73% on the webinar have no experience or knowledge of leak detection systems at all. 20% have used it once or twice, and 5% are a regular user.
That's grand, Andy. Thank you. I would also say if none of those poll options apply to you, please let us know through the chat why you're interested, because we would like to know. It'd be helpful to us. It'd be helpful to the PCA for the future. Okay. I don't have a detailed history of electronic leak detection. We are aware that it was used in laboratories a century or so ago, though other mechanical forms of leak detection long precede this, of course. As transistors and solid-state electronics became more commonplace around 50 years ago, you know, back when electronic calculators were still cool, the first really portable instruments began to appear. Once testing became mainstream, national and private standards organisations prepared and published various procedures, standards and test methods which they recommended for use, and these are likely to be reflected in contractual requirements for testing. Excuse me. Whilst there is a range of technologies available, the key approach for all of them is to find a difference. Most instruments detect the difference in conductivity between the top of the waterproof layer and the structure below. Others detect the presence of water by differences in heat capacity or other physical effects, such as the inductive effect of water under the membrane. For a conductivity method to work, the membrane itself must be non-conductive, and there needs to be a conductive layer below the membrane. Dependent on the detailed design of the deck or roof, there'll be a number of layers, including a structural substrate and a waterproofing layer. There may also be insulation above and below or below the waterproof, drainage, water retention, green roof bedding or decking layers. In order that the portable electronic systems can function reliably, they must be carried out when the waterproof layer is directly accessible. And the substrate or the layer below the waterproof membrane or coating needs to be conductive and grounded. In remedial work, where there is evidence of water infiltration, it's very likely the water itself will form the ground path between the leak and the building structure. This will be very helpful in finding breaches in the waterproofing layer. So let's dive in and look at the range of wet methods. We'll start with permanently installed systems. Permanently installed systems rely on a grid, either of discrete water sensors or perpendicularly arranged conductors. The electronic scanner monitors these conductors to determine whether there's a leak, and if so, where in the grid it is located. Clearly, such systems are intended to be installed when the roof or deck is being built, though it would, in theory, be possible to install such a system during a substantial refurbishment. The resolution of installed systems will have a direct bearing on the installation cost, but will of course offer the option of greater precision in the localization of any leaks that are detected. Because installed systems do not depend on direct access to the waterproof layer, they are able to operate under green or blue roofs, and also with podium deck superstructures in place. The systems can be integrated with other building management systems such as fire and intruder alarms to provide comprehensive coverage. In stark contrast, the wet sponge method uses a handheld unit fitted with, well, a wet sponge. A ground wire is connected to the item to be tested and the sponge is wiped over the test item. While some construction standards do refer to this method, it's really only suitable for small areas. It's commonly used, for example, in industrial and automotive paint finishing. I'd certainly not recommend it for anything other than small, smooth surfaces, details perhaps. The wet roller method is a very similar technique, but quite a bit bigger. The roller is kept wet by a continuous pumped supply of water from the tank, and the operator can progressively cover the entire area, starting from the lowest point and working upwards. The surface needs to be dry before testing begins. Due to the water supply and the larger roller, this technique can be applied to decks, roofs and smaller geomembranes. The water lance method uses essentially the same equipment but simply increases the scale. It's perhaps more suitable for geomembrane applications rather than decks or roofs. It is necessary that the water supply is both plentiful and isolated. The pump will need to produce significant pressure, but the operator can cover fairly large areas pretty quickly. Again, it's necessary to start at the bottom of any slope and work upwards. And of course, prior to testing, the membrane or waterproof layer should be substantially dry. With voltage field measurements, a thin layer of water is spread across sections or the whole of the area under test, which is bounded by a field electrode, the trace wire. The generator applies a voltage between the field electrode and the building ground. The technique is applicable to substantially flat surfaces, including decks and roofs. It can also be used on shallow slopes. If there are flaws through which water can penetrate, a current will flow between the electrodes, and it will be indicated by the generator. This shows that there is a leak in the area being tested. The voltage field that this creates is rather like an invisible mountain. If there are multiple leaks, there will be multiple peaks. The detector, which you wear around your neck, enables the operator to see where the top of the mountain is. It's a little like standing on a mountain with your eyes closed and putting your ski poles on the floor. You feel which pole is higher. You'd know which way to the top of the mountain. You could use your poles to feel your way to the top of the hill. This is a little bit safer. You don't have to close your eyes. The voltage field wet test approach is ideal for surfaces that are substantially level, smooth and do not have numerous grounded items within the area to be tested. It's also the preferred method to be used when it's raining. If there's one takeaway, the wet method is likely to give the quickest results in locating the sources of leaks in old buildings where established leak paths are known to exist. And now I'd like to give you a brief video of voltage field mapping in action. Lay the trace wire to form a border around the area you wish to test. The testing surface should be thoroughly wet, either through rainfall or by soaking it with a hose. The trace wire should make good contact with the test surface. Hold the red test probe in the right hand and the black test probe in the left. Make sure the wires do not cross over or get tangled. Place the tips of the probes on the ground. When the generator pulses, the detector display will indicate the direction of the fault. Continue the search, moving in the direction of the pulse until the reading swings in the opposite direction. At this point, turn through 90 degrees and repeat the procedure until the crossover point is reached. You have now located the leak. Mark the position of the fault and continue testing. I hope that showed you how simple it is to use. Now, moving to the dry methods, as noted before, these techniques are rather different to the ones we've looked at so far. Infrared cameras are a convenient method of detecting water hidden beneath a membrane. Water has a very high specific heat capacity, thus it can be readily detected by a temperature difference between a wet area and a dry area. This is particularly effective early on sunny mornings when the dry areas of a deck will warm much more quickly than any that are saturated. And at night, of course, when the damp areas will take longer to cool. This method proves that water ingress has occurred. It typically does not provide specific guidance in the location of the leak that allowed it. Induction instruments apply an alternating electric current to the roof via one antenna and measure the return signal via another. If water is present within the roof structure, this will be registered as a difference from areas where water is not. Some tuning of the instrument will be required to suit the roof structure. Instruments are available as a push-along, as shown here, very similar in size to a lawnmower, or as handheld detectors, which are somewhat smaller. Again, the method proves that water ingress has occurred, but typically it does not provide specific guidance in the location of the leak that allowed it. Arc testing requires much higher voltages than wet methods, in a range similar to automotive spark plug voltages. A scanning approach is required for dry methods. A battery-powered high-voltage source is connected to an electrode that is brushed across the entire area to be tested. The instrument is normally carried in a shoulder bag, and the ground wire is connected to the building ground. The necessary test voltage is dependent on the thickness of the layer to be tested, with an additional allowance. Various published standards exist that provide this information. The better instruments also provide automatic voltage calculation according to the various published standards, allowing you to directly input the thickness of the material to be tested. The instrument will calculate the voltage. When a flaw is detected, the instrument will flash an alarm and the operator can manipulate the test electrode to detect the exact location of the fault. The operator places the brush on the surface to be tested and presses the button on the handle. The screen backlight turns blue to show high voltage is turned on. On finding a fault, the backlight becomes red and the alarm sounds. It is possible to lock the instrument on so the button does not have to be held down. And now I'll show you a very brief video of an arc tester in operation. Let's start with the earth lead. Connect the crocodile clip to a suitable earthing point. Connect the other end to the 50-meter earth extension reel. Ground connections are really important. Start by sweeping the electrode across the testing area. When a fault is detected, the instrument will sound an alarm and the screen will glow red. Use the corner of the electrode to identify the location of the fault. The spark should be visible to the naked eye. Mark the position of the fault and continue testing. Trying to keep a large, flat, possibly windswept air and sun-baked roof wet would be extremely difficult in hot and dry climates. Even in the UK, in summer conditions, this can make the wet approach difficult, and the dry method is clearly preferable once the dew has evaporated. Couple this with the convenience and portability of a dry roof pro tester, and it's the go-to choice for many inspectors. The sequencing is important. Regardless of the approach used, inspection for and detection of leaks on a rooftop substrate before occupation is crucial for the architect, building and roofing material suppliers, and contractors and clients themselves to ensure the building meets and will continue to meet design and specification. Even if a permanent monitoring system is specified, it makes sense to inspect thoroughly before any overburden is added. If the waterproof layer will be covered by a traffic deck or vegetation layer, and particularly so if a permanently installed system is not used, it's vital to ensure waterproof integrity. Okay, I'd like to look at a case study that came across my desk recently. A customer who carries out independent inspection was requested to report on the following structure and asked our advice. He'd been provided with the roof cross-section that you can see here and wanted to know what we thought. The first thing that stands out is that there's 320 millimetres of insulation topped with a water flow reducing layer, a 15mm slab support layer and 50mm slabs. Clearly, there's no way of using a portable inspection equipment to test the hot applied waterproof layer if it simply isn't accessible. Presuming that access to the waterproof layer is possible before the insulation and other parts are installed, there is a second issue. If the WBP had been screwed down and coated whilst bone dry, it will be a very effective insulator. Whilst the screws will provide a grounding path, they will not provide a sufficient conductive layer to enable electronic leak detection to work effectively. It is noteworthy that had the hot applied waterproofing layer been applied direct to the concrete, this would have provided an effective grounding layer, and testing would provide a high degree of confidence that the waterproof layer integrity had been achieved. Another option would be to provide a grounding layer below the hot applied waterproof layer, and a number of proprietary conductive fabrics exist specifically for this purpose. Driving the fixings for the WBP through such a fabric would ensure effective grounding, and again, a high degree of confidence would be obtained from such an approach. Clearly, this technique would require agreement of both the conductive fabric manufacturer and the waterproofing material suppliers to ensure product compatibility. And I would obviously recommend testing before adding the insulation and topping layers. I think it's also worth considering in a remedial situation where the building has been in use for some time, that if flaws leading to leaks have occurred, the water will have entered the building through the structure of the roof space and will have infiltrated, possibly tracking several metres before becoming evident within the living space. In these circumstances, electronic leak detections are extremely useful in locating the sources of the water leak, as the water itself acts for a conduit for current in both wet and dry systems, and both would typically be able to detect the source of the external flaw that allowed the water to enter. Before moving on to taking any questions, I'd like to offer you a summary. The simple fact is there is no one best system, but the various systems do have their various strengths and weaknesses. First and foremost, I'll repeat myself one last time. With the exception of permanently installed systems, it really isn't practical to locate leaks through podium decks, green roof planters, blue roof rainwater tanks, or layers and layers of insulation. If you're trying to find a leak, get down to the waterproof layer or membrane. Permanently installed systems do add to the first cost of the building, but they give you that peace of mind from being always on. At the other end of the scale, the wet sponge is a simple way of finding small faults, but is very limited in capability. The wet roller and water lance both use the same equipment and approach. They're quite commonly used in the US. They seem rather less common this side of the Atlantic. Voltage field mapping, as you have seen, is a very capable system for both liquid applied and membrane waterproofing systems. It's likely to be first choice when looking for entry points of known leaks in remedial work. Thermal imaging allows quick and effective surveys to be carried out, but like the inductive systems, it requires some effort to locate the entry point. High voltage arc testing is very easy to use. It's portable and efficient, and it's probably the first choice when the weather permits. I'd like to thank you all for listening. If you'd like to submit your questions, Andy will pass them to me. I'll do my best to answer them. Andy, over to you.
Simon, you've caught me off guard there. I wasn't. I literally wasn't ready for you to kind of pass back across to me. I think you are, by record, the quickest person that's ever kind of gone through in terms of time on the webinars. I'm
sorry, I do a bit of a Patrick Moore. I have a habit of talking very quickly. I apologise for that.
Well, folks, I will say this, there's not a lot of questions that have come through. Most of it has come through via email to myself. Now, if you do have any questions, then now is the time. I think one of the big questions going to start off with, which I think probably wasn't quite clear, and I think Ross McDonald in an emailed it across to me just there, which was for him, he could, in terms of existing buildings, in terms of buildings, this is not new build, this is not as we're building the layers, no, and testing the layers as we're doing the building itself. I mean, what can you actually use that will help test the building, test that the waterproofing layers are okay or not? I mean, what tools could you use?
Right, I'm looking out the window at the moment. There's a building right across the road from us. It's got an asphalt applied flat roof. It's pouring with rain. If I was unlucky enough to need to test that today, I'd be out there with a wet test kit. I would lay a trace wire around the edge of the building roof, possibly in sections because it's got a couple of skylights there. And I would use the wet tester to look for any voltage field that I could find on the roof. That would give me an indication of sources of leaks into the roof structure. That would be my first port of call. You could also use a capacitive or inductive sensor to see if there's water trapped within the roof structure. But as I said in the presentation, they say that there is water in the roof. You might know that because it's dripping inside the building. They don't necessarily tell you where the water got in from, whereas the voltage field mapping will give you a very clear location of a hole in a membrane, which would be helpful. But I mean, to take the question a bit more broadly, if you've got, I mean, clearly this kind of system isn't going to work on a slate roof, a pitched roof. That's not going to be the right approach. If it were a very hot, dry day, I would probably use an arc tester to test the same kind of roof. And again, that will give me good capability to locate the sources of any damage or holes in the roof to find where the water's got in.
Right, okay. Well, here, moving on to the next question. Now, this question is actually something that's been asked by several people, but I'm going to take the question that Jason Colburn has actually kind of sent across to me, which is associated with layers and the detection of faults through layers. Now, are there any waterproofing layers that can actually be accurately leak detected? And is there anything else, I suppose, that could cause inaccuracies? Jason Irvin, for example, is suggesting would bubbles, for example, set off negative signals? Do you know? I don't know if that's okay.
I think there's a few questions wrapped up in there. I'll try and pick them out. I think the first question was, are there any layers that can't be tested? I've stressed in the presentation, you need to get down to the waterproof layer if you want to use electronic detection, unless you've got an installed system. If you got down to the waterproof layer, you're then dependent on two things. Firstly, that the layer itself is not electrically conductive. And secondly, that there's an electrically conductive layer beneath it. Now, that electrically conductive layer beneath could be water. If water's got into the system, into the roofing structure, you'll be able to find that because assuming there's a hole to get to it, and that's how it got in, that's what it all depends on. However, there are a couple of materials we're aware of which are really, really difficult. One of them, widely used in the US, much less so over here, but an extremely effective roofing material is EPDM. EPDM is very similar to the rubber your car tires are made from, and it's got a lot of carbon filler in it, and consequently it's conductive. It's sufficiently conductive to completely disable any kind of arc tester from being able to work on it. And you can, in some circumstances, get some results with a wet tester, but in general, I would suggest you're going to struggle. There are some proprietary materials which we're aware of, and I'm aware of one protan material which has also got a carbon filler in it, and that too, for the same reason, is conductive, and we have had feedback from customers that they've struggled to test that. So that's the first thing. I think the second thing is what's under the layer. If you're down onto wood, if the building's fairly old, and if there's been water leakage, the wood will have a dampness in there that will enable it to be conductive. So you don't need to worry about that too much. And as I mentioned, there are things like Celotex that possibly foil-faced insulation. The foil facing acts as a very effective grounding layer under the waterproof layer, and that allows you to test effectively. Voids and bubbles. Voids and bubbles are generally not a problem with the conductive method. So arc testing or voltage field map testing, voids and bubbles won't make any difference at all. I'm not sure of the effects that voids and bubbles might have in inductive systems. A void will appear as a cooler or warmer area in thermal testing, but the chances are it's not going to be so big as to be confusing.
Okay. Do you know something that strikes me? This is me being a little bit selfish, because this is probably this is a question for myself rather than the audience. But it strikes me, and I'm going to bolt this onto as well to something that Naheem also mentioned. But when you're doing this testing, I mean, how long are you really looking at kind of having to do like a roof? And you know, and following on from Naheem's question, I mean, what sort of cost are we looking at here that surveyors and construction professionals would really have to take into account before kind of passing that on in the reports? I mean,
okay,
a piece of string.
Yeah, I've got a piece of string here. I think the actual process of testing, you saw in the brief video of the arc testing, effectively you're pushing a brush along the roof. Now, I think it's probably fairly easy to estimate how much you can cover in an hour. I would suggest you're walking between 2 and 3 kilometers per hour. Let's say 2 for easy numbers, and you're probably using a 1/2 meter wide brush. So you're going to do about 1,000 square meters an hour. That would be relatively easy. And that would probably be reasonable as well for the wet roof. Pardon me, the wet roof systems. The questions that I can't answer are: how long does it take you to get to the site? When you get to the site, do you have to go through site briefings? Do you have to? A lot of sites have very controlled access. Once you've got on site, how easy is it to get to the area that you're actually going to do the testing of? Does it involve carting your equipment up many flights of stairs and then some ladders? Or is there a lift? When you get on site, is the roof nice and clear, or the deck? Is it nice and clear, or do we have skylights? Do we have solar panel installations? Do we have lots of earth things sticking up through the membrane? Because they obviously have to be excluded from the survey. So there are a lot of things that I can't give you a clear answer about. You need to do a site survey and see how easy it is to access and do. But in terms of actually doing the testing, I think as a quick and dirty, I would expect to do 1,000 square meters an hour, and you could possibly go a bit quicker than that. Depends on the site. And then, of course, afterwards, you've got your report writing to do. You've got to put that in a format that the customer's going to be happy with. Does that answer the question?
Yeah, to a certain degree. I think to summarise up, the bigger the longer it takes, and probably the more cost that it is.
I think it's a bit like mowing a lawn. You know, if you're mowing a suburban back garden, it won't take as long as mowing Wembley.
Fair enough. Well, yeah, I've got some more kind of specific questions. Paul Sweeney's asking, what is the best leak detection test where a single ply roof membrane is used on plywood on a timber roof structure?
Yeah, the plywood on timber roof structure is going to be a problem, and I alluded to it earlier in the presentation. The plywood itself is, unless damp, is going to be pretty insulating, and the timber roof underneath is not going to provide you with a grounding path. So unless you've got a conductive fabric between the waterproof layer and the plywood, you're probably going to find electronic systems quite difficult to use. If it's a new build, visual inspection, you can do a wet test, but I'm not going to guarantee it'll give you reliable results. There's a question here. Proving that there isn't a hole is not the same as not finding one. So it's quite easy to test something and not find some damage. It's quite a lot more difficult to test something and say with confidence there isn't any damage here. And I think any testing has to be approached in not just roof testing or deck testing or the instruments that Buckley's produce, but any kind of test. And it came up indeed, obviously, in the recent COVID story about false positives and false negatives. And what you're looking at here is the possibility of a false negative. I've tested this roof. I didn't find any holes. Therefore, there are no holes. And that, therefore, isn't necessarily true.
Right. OK. I mean, are you suggesting that, I mean, should we be doing this periodically, especially if there's ever any repairs on a roof? We should be testing to make sure that any kind of repairs that are done on the roof have not done any damage to the waterproofing layer. Is that what you're maybe suggesting? Well,
the roofing and decking people with whom I've worked would generally go out. I mean, if we're talking remedial, they'll be called out because there is a leak apparent. It's dripping in the frozen product aisle of the supermarket. So they go out and they're going to inspect the roof and they're going to try and find the leak. And typically they'll be able to do so. And when they find the leak, it's then a question of assessing. And this is way outside my expertise and field of knowledge at all. But you're going to have to assess the roof and say, has this tracked for meters in the insulation? Is there damage in the roof structure or the build-up that I need to address before I fix the leak or after I fix the leak? I'm then going to I found the leak. I need to repair that to stop further water getting in. And having repaired it, I would generally do a test to prove that the repair is good. Whether that is sufficient, I mean, I certainly don't think anyone would be recommending regular inspections like an MOT test. That's probably fairly unusual, I would think.
Well, okay. Well, do you know, David Christie has raised an interesting question. I didn't know these sort of things existed, but I know the topic of this particular webinar was about electronic leak detection. But he's asking, what's your knowledge like with regards to ultrasonic leak detection? Is that something that's used within the construction sector? And if so, is it any good?
Ultrasonics are used typically, in my experience, for thickness measurements. They're extremely effective for example, measuring the thickness of a waterproofing layer on a metal pipe or a ship. I was involved in some work with a ship a few years ago where they had carried out ultrasonic thickness tests on a composite material, waterproof material that was wrapped onto the propeller shaft. They knew the material was thick enough. The ultrasonics had measured that. They're using our equipment to prove that there wasn't any pinholes or leaks within that waterproof layer. I'm not familiar with ultrasonics being used for leak detection per se. Thickness measurement, absolutely. Extremely good, very effective. I'm not sure. I'm not familiar with it being used in the construction sector at all.
Well, okay. Well, folks, I'm going to throw it out there. If you are familiar with it being used in the construction centre, then go into the chat, let us know. Tell us. Yeah, I encourage you to do so. Moving on, I've got a question from Richard Osborne. He's asking, what is the best method for testing GRP roofs? Now, I'm assuming when he says GRP roofs, he's meaning glass. Yes.
Yeah. GRP is an extremely durable material. If it's applied at the proper thicknesses, back to your ultrasonics again, it's an extremely useful material. It's widely used. It's extremely versatile. Everything from roofing to boats to parts of aircraft to you name it. It's got all sorts of applications. The issues with GRP are twofold. It can be applied, let's say, not terribly effectively, and pinholes might continue or might exist in it. And assuming there's some kind of grounding surface below the GRP, damp timber, for example, an arc testing method will find those pinholes very effectively. And the other thing is that it suffers from osmosis. That was something that was particularly prevalent in the boat market maybe 30 years ago. It still happens today. If you get fresh water sitting on GRP, you can, if the resin system isn't right, or if it's not mixed correctly, you can get water actually going into the structure of the resin, and that can cause problems. And in those cases, a conductivity meter, such as you might use for checking concrete wetness, dampness, or wood dampness, will be able to tell you whether you've got water actually within the structure of the fiberglass. Simply looking for leaks, I would tend to use an arc tester.
Right, okay. All right. Well, do you know, I've just, there's an interesting question that's come in from Phil Pettinger. It goes in that old concept that sometimes a job is only as good as how skilled and qualified a contractor or workie is. Now, he's asking that from his perspective, there seems to be very little in the way of regulation for testers of these sorts of systems, especially testers of kind of almost membrane layers and etc. I mean, is there certification that is available out there that kind of proves that a tester is knowledgeable and experienced in this sort of thing, that would then sufficiently lead to him then correctly going ahead and testing roofs with the person appointed having the confidence of knowing that he's done the job right?
Thank you. That is actually a really good question. We were involved with a couple of contractors in the UK some years ago in trying to set up a module within the construction industry training programs. Forgive me, I'm not familiar with the details of it. It didn't happen in the end. I don't know whether it went ahead with other parties. What we do when people buy our instruments is we provide either online or face-to-face training. And normally we would provide that free to anyone that buys the instrument. They get a 2-hour training session, and the training session will be followed up at the end of the training session. They'll get a questionnaire to answer, and if they pass the questionnaire, they do get a certificate saying they know how to use our equipment. That's not quite the same as saying that they're certified to test a roof, but they certainly would be able to demonstrate they can use our equipment properly. I would be interested if there are colleges or industry bodies that are setting up certification. I think it can only be good for the industry for there to be clear certification to say, Fred has passed, the theoretical and practical aspects of testing these, and he knows what he can test and he knows what won't work. It comes back to that false negative issue. How do you know that you're going to have or could have a false negative? It's a combination of skill, knowledge, and experience. And we all know the story of young drivers. Because they've got the car doesn't mean they can drive, and just having a piece of testing equipment doesn't mean you can do a test on which you can rely.
No, I completely agree, and I think from certainly a consumer point of view, I mean, having the confidence and knowledge of knowing that certainly that person is actually skilled and knowledgeable in how to actually do it, and the results that are actually coming back are actually reliable and accurate.
Yeah.
I mean, that takes time. That takes time, and evidence, having that certification helps as evidence to gain that confidence, certainly for the user. And I suppose to a certain degree, if people want to embrace this technology, they have to have that confidence and be able to pass on that confidence to whoever they're reporting to. But moving on, because questions are actually coming in really thick and fast.
Good.
I'm going to actually move on to a question from Zalina. She's asking, what happens if you have no idea of what is below the surface of a flat roof before you actually go to test it? Right.
Okay. Well, I mean, the experience thing we just talked about, you'd look at it, and I suspect anybody that's experienced in the field is going to look at it and go, well, it's probably, and they're going to look from inside and outside, and they're probably going to have an idea of what they might find. the next question they say was, what's the most appropriate thing I can do? And they're probably going to put their hand out and go, yeah, it's raining, I'll use a wet tester, or it's hot, dry and sunny, I'll use a dry tester and see what I get. One of the things we advise, and it's not always practical, but where it is good practice, to pull up a bit of the membrane, have a little bit of a look. I mean, obviously hot applied, you can't pull it up if it's liquid applied. But if it's possible to have a look at the membrane and see what lies below it, that's always a good idea. Does mean you're going to have to do a small remedial work to patch the bit that you've damaged, but deliberate damage is sometimes a useful way of getting the insight as to what to do next. Thermal imaging camera, probably quite a good way of approaching it if the weather's being helpful. Otherwise, yeah, as I say, I'd probably approach you with a wet or dry tester and see what I got.
Well, sticking with tools and techniques, Nick Wells has just pinged a question asking, are there techniques for testing upstands, thresholds, parapet walls and junctions? Yeah,
this again is a really good question. That case study I showed, there was an upstand parapet on that. One of the NACE specifications actually recommends the wet sponge tester. You'll remember I said that's an effective method in small areas, and you can use that to wet test vertical surfaces. It's not very easy, it's not very quick, but it will work. The arc testing will work on vertical surfaces and indeed even overhanging surfaces. We did some interesting work. It's not directly relevant to building industry, but there's a company in New Zealand that makes a robot. It's a little robot crawler that clings onto surfaces, and the surfaces can be vertical or even upside down. They have a video on their website of it crawling along the underneath of the wing of a jumbo jet. And they use that inspection, and they actually fit it with one of our high voltage probes for testing the inside of reaction vessels in the chemical industry. You don't want to send people into confined spaces. That's become a major no-no from a health and safety point of view. So this inspection robot, carrying a high voltage probe, and is able to, and a video camera, and is able to video and high voltage test the whole of the inside of this reaction vessel. And that was really quite an exciting project to work on. Trying to get back to the relevance of the question. Yeah, take me back, Andy. Where were we going with this?
Well, it was just about the techniques that you could use and the tools you could use.
Vertical surfaces, of course. Yeah, so the dry tester, the arc tester, is capable of working on any orientation of surface. Obviously, flooding tests are very difficult to use on anything other than a broadly horizontal and smoothish surface. Though, if you're faced with a big upstand, maybe the Waterlands test would be a way to go. It's not something I've got very much direct experience of, but the Waterlands would give you the opportunity to spray a vertical wall.
Okay. Well, do you know, just because we were talking about health and safety stuff there, I think it probably is nice time to maybe pose this question. I mean, Naheem has posed the second question here, which is quite rightly said. I mean, what are the critical health and safety measures that you really need to be aware of, especially if the fact that, I mean, in one of those videos, I was seeing electrical arc currents passing across. I mean, are we at risk of being electrocuted here?
Absolutely, but it was.
I wasn't expecting that. Yeah, to see that.
Andy, you said earlier that you hadn't had the pleasures of owning a motorbike. I'm sure some of our audience have, and if any of them have had an old motorbike, they're very likely, or an old Mini, the old British Leyland Mini. There's a very good chance that they've taken a belt off the ignition system because it just happened. You did, and it makes you jump. It's very, very unlikely to do any more than make you jump. But similarly, the high voltage instruments, they can give you a belt if you don't follow the instructions. You'll see in the pretty picture, indeed, if I can very quickly, I don't know if I can get there. I want to get back to that picture there. My colleague Chris, you'll see he's holding the handle by the black part. He's not holding the red part, and there's a very good reason for that. So yeah, the instructions are quite clear. Now, it's high voltage. It can be these instruments, depending on which model, will produce up to 40,000 volts. That is obviously something that will sting. They are limited. They will not. They are CE marked. That says that we've tested them to ensure that they don't produce a current that is considered by the International Electrochemical Association to be dangerous. So they are safe, but it still hurts. Now, I'll go one stage further. If you're up a ladder and you give yourself an electric shock, you might fall off the ladder. So that's something you want to be careful of. And I guess there is one thing that we do make very clear. If you have a pacemaker or any kind of implant, we would advise that you don't use these instruments. There's no direct evidence that a pacemaker would be affected by one, but I really wouldn't want to be taking the risk. And similarly, if you've got an implant glucose monitor, or there's various other things, infusion pumps and stuff like that. But I guess people wearing infusion pumps probably wouldn't be using high voltage equipment anyway. Those are areas where I'd be extremely careful, and our instructions and training clearly say don't do this.
All right.
The other sorry, Andy, the other health and safety thing, obviously, if you're working on a roof, there's a whole load of health and safety to go with working on areas where you can fall off. So do be aware of the fall protection and the other things that might be relevant to the site on which you're working. Fair enough.
Well, folks, many thanks for everyone kind of holding on over the kind of questions. I don't have very many more questions to ask you, Simon, but the next question is a little bit more of a controversial question, and feel free, anyone, if you want to come in on the chat on this. But Hugh Butchell has commented that from his experience, people that have used electronic tests on timber, moisture or dampness buildups and have reported to a certain degree no defects, but subsequently afterwards leaks and inspections have proved otherwise. I suppose what that leads me on to maybe asking is, are there typical difficulties when using equipment like this that can potentially bring about a false negative?
Yeah, I mean, the conditions for an electronic leak detection system to work are that you have to have an insulating membrane or layer, let's say. It could be hot applied or membrane. And underneath it, you have to have a conductive layer. If you don't have a conductive layer, you're going to run the risk of a false negative. And if you've got a conductive top layer, you're going to have a false positive, potentially. So, this again comes back to the understanding of the operator or of the specifier. There is no point in specifying a test that won't work. So if the roof is, let's say, a ply roof on top of a wooden structure, it might be pitched or it might be flat. If it's built like that, the chances are, and if it's new especially, it's going to be dry. You would hope that the roofing contractors are going to put the waterproof layer onto dry timber rather than rain-soaked timber. And if they do so, leak testing is going to be extremely difficult. And I think, we have to be very upfront about that. I don't want to sell someone a piece of equipment and then come back and say your equipment doesn't work, when actually it's a question of you're trying to apply it to something it can't do.
So I suppose this is quite, because it almost kind of loops back onto this point that we were talking about there, about the competencies of an individual and their skill, knowledge in using the equipment. I mean, it's almost critical now. Critical that there's evidence to kind of show that individual is skilled in knowledge if these false positives can come about.
I think that'd be a very good thing if there was, you know, if there was an A level in roofing or roof inspection.
Oh yeah.
Whatever it might be, you know.
No, I get that. No, it's just okay. Well, I suppose my last question, I'm going to kind of fire over to you, and again, it kind of sticks on this health and safety thing. Comes from David Christie. Is there actually any fire risk with arc testing? For example, near a gas appliance.
Right. Yeah. Yes, of course there is. I've actually, the things that crossed my desk over the years, I've actually had a guy asking me if it was okay to test the roof of a petrol station with an arc tester. And my answer was, no, I don't think I'd recommend that. You know, it's... Very clearly, an arc tester is producing an arc, and if there's flammable vapor in the area, it will potentially ignite that flammable vapor, and that could cause either a minor flash or it could cause a major explosion. It is absolutely the operator's responsibility to ensure the safe application of the tools. We're very clear that explosive atmospheres are a very definite no-no. That said, with the appropriate precautions, you can. I have actually been in a missile manufacturing facility, and we did testing with an arc tester. But you better believe the precautions that were taken before we were allowed to do the testing were very, very significant. But again, it's down to the site safety manager. They need to understand what's happening. They need to say, yeah, it's okay for you to go ahead and test with that type of test. I would counter that also by saying, if you feel that an arc test is potentially risky in the particular application, you can always try and use a wet test. The voltage field mapping runs at 32 volts. There is no chance whatsoever of creating an arc.
All right. Well, I'm glad to hear that you declined the petrol station job, and certainly if you're going ahead, I would be volunteering for that. Well, here, folks, many thanks for all your kind of questions. Just for those looking for any additional information, if you do want to find out more about the technology, then you can always contact Simon at Buckley's directly for any kind of information, guidance and advice. For those, however, that are interested in finding any additional information about waterproofing guidance, then I'd certainly point you over to our PCE website, where you'll find a whole variety of codes of practice, best practice documents, and plenty of support information. For those that are interested, I have just stuck some links just into the chat there that you can find out a little bit more. Of course, as well, the replay of this webinar will be available to all come tomorrow. If you are also, by the way, which I forgot to say, if you are watching the replay on this and you do have a question that wasn't addressed over the question time there, then please feel free to email me at andy@property-care.org. That's andy@property-care.org. And I will do my best to try and get that question answered for you.
Yeah, I'll be very happy to do that, Andy.
Oh, thank you, Simon. So, in terms of our next webinar will now be in 2023. We don't have details of that webinar up yet, but it's currently being worked on. It will be associated with mold, condensation, and ventilation. So look out for more information coming soon on that. But certainly there's a whole library of previous webinars. In fact, this is episode 40 now. So there will be, come tomorrow, 40 online, ready to go, on demand webinars for you to kind of go on there, digest, and knock yourself out with in terms of online learning. Last but not least, I just firstly want to say a big thank you to yourself, Simon, for coming on and sharing your knowledge and giving us all a little bit of insight there. I want to also say a big thank you to everyone that joined us this morning. And lastly, hopefully everyone has a lovely rest of the morning, and we hopefully see you in 2023.
Thank
Take
you
care,
all.
everyone, and goodbye.
Bye.